So, my name is Apurva Chaturvedi, and I'm a senior clean energy specialist at USAID India. A very good morning and good evening to people or participants from wherever, whichever part of the world you are. Um, and a very happy new year also, although for both US and India, at least the year really hasn't started with a great note with the third wave of the pandemic in. However, good thoughts and good ideas keep moving, life keeps moving, and therefore we are here in the ZerO-In dialogues that we've initiated as part of our US India bilateral METRI program, which is a program on market transformation for energy efficiency in buildings and cooling. Uh, with and this ZerO-In dialogues actually is a series which basically is pushing the sector, the power sector, basically towards grid interactive net zero energy buildings, which demonstrate high performance. They have low environmental impact, and they also offer flexibility to the grid. So far, the buildings have been seen as a standalone kind of a subject separate from grid services. But that's where the ZerO-In dialogue is trying to bridge that gap and bring synergies between buildings, which can be seen not as a part of the problem but actually a part of the solution for a smarter grid. And as the grid becomes increasingly complex, the flexibility in the demand would play an important role in maintaining grid reliability, improving energy affordability, and integrating a variety of generation sources. So that's what we are trying to address and trying to build in a new kind of a narrative in the Indian context, which is also relevant for this part of the world in the South Asia, Southeast Asia as well, that buildings are then seen as a crucial last mile element of a smart grid of the future, and the demand flexibility which is offered by buildings and appliances uh, offers a great opportunity for the distribution utilities. So this whole concept of grid net zero energy buildings can actually serve the need of both the consumers as well as the distribution utilities while reducing the overall energy consumption, balancing the energy demand, and then providing the best economic value to the energy supplier and the customer. So this we are now today in the third of the series of the ZerO-In dialogue, which focuses on consumer engagement. And very glad to have Mary Ann from Lawrence Berkeley National Lab from the US joining us to talk about CalFlex Hub, a platform for advancing dynamic energy management. We would also have another Mary, Mary Tyler Holmes from USAID India, who joined last year as Deputy Director of the Indo-Pacific Office at USAID. And she comes with a wealth of experience, having worked in different parts of South Asia, in different countries on a lot of issues related to climate change and she's very well aware of the context of South Asia and is a great champion for new ideas and new thoughts. We also have Atul Bali, who is the Chief General Manager of National Smart Grid Mission of Government of India, which is our partner agency for this whole ZerO-In dialogues. And because he hems the National Smart Grid Mission, which is a nodal agency of the Government of India for promoting smart grids, deployment of smart grids in the country. We This is a perfect convergence of grids and buildings in the true sense in terms of partnership. And Atul brings in a lot of experience of the power sector, having hemmed a lot of projects on distribution upgrade management on some of the key schemes of Government of India in distribution. He comes from Power Grid institution. Of course, as we'll go forward in the agenda, I'll be introducing each of the speakers again. But again, a very good morning to everyone. And I would now just so the whole purpose of this grid interactive net zero energy building ZerO-In dialogue is that we want to build we want to promote this concept in India, as well as in, as I said, in South Asia as well. And also, along with the dialogue series, we are also involved in a couple of projects, which are actual deployment projects, where we are supporting the design and construction of a grid interactive net zero energy building in one of the state in two of the states in India. The projects are underway, and the whole reason why we have gone with this approach is that on one side, while we continue to have a dialogue and a deliberation with the right stakeholders in mainstreaming grid interactive net zero energy buildings as part of a smart grid of India, but also simultaneously, as they say, seeing is believing. So have actual on ground projects where the techno commercial feasibility of this concept is tested on ground through these actual projects or actual buildings, which would then interact with the grid. So, with that, I would turn over to Piyush now, Piyush Verma from EDS, which is our implementing partner for METRI, to take us through what grid interactive net zero energy buildings actually mean and from a consumer engagement perspective. So, over to you, Piyush.
Thank you so much, Apurva. I hope you all can see me and you all can also see my screen. I will just be switching on to the presentation mode.
Yeah, we can.
Yeah, so
Yeah, go
good
ahead.
morning, good afternoon, good evening from wherever you're joining. It's really great to have you all here. I have this exciting opportunity to set the tone for today's dialogue series today. And I will be presenting this in context of, or I'll be presenting consumer engagement in context of grid interactive buildings as well as demand response. So, but how do we get there? So, just to say it in other words, although Apurva said the context very clearly, but just put it off as a story. So you design this building and just connect it to the grid. Um, you make it energy efficient, and just to be able to get to the net zero goals, you add renewables to it. Now, as soon as you do this, you realize that there are these problems. A building, by its very own nature, is and its operations are very stochastic in nature. Why? Because of weather uncertainties, because of how appliances, equipment, and other things behave, and also how we behave, the users or the consumers. And this kind of throws off many problems, and just a few of those problems. Is the variable generation getting into the system? Are you able to use it? Are you able to use it when you're generating it? If not, where is it going? Does it uh, affect the grid? Does it throw it off balance? So what are the solutions? The solution is to become a grid interactive building, and it not only meets your net zero energy goals, but it also begins to start meeting your climate goals. So buildings essentially are a key aspect in making the system reliable, flexible, and agile. So buildings are the next frontier in flexibility, and this has been well recognized. There are already demand response requirements in building energy codes coming across the world now. So now getting to what we're going to talk about today. We're going to talk about what are the basic means of integrating demand response in building, um, what kind of consumer engagement opportunities these programs bring in, and how can and what are the benefits that a user gets out of these things. So at the crux of it all is when we ask a consumer to participate in a demand response program, what is in it for them? So in a nutshell, demand response can be broadly implemented in by three ways. Having a manual demand response, uh, which requires a high level of user involvement, but little or no instrumentation, and therefore very little investment. On the other end of the spectrum is an automated demand response, which talks about high level of instrumentation, limited user involvement, and this also will, and why there is less user involvement is because at some point in time the machines start learning and start adapting to your needs and to the grid's needs. Uh, but and then there is a third component which is kind of mix and match of both. Uh, but key here is that the manual demand response and semi-automated demand response at least hinge on behavioral nudges. So how can you affect someone to say turn off the air conditioner when it's a peak period for the grid, right? And the demand and the automated demand response takes it a step further and integrates learning systems into this. So I'll be explaining these through three very simple case studies, and it'll be like an overview of sorts. Touch upon points on how are we actually engaging with the consumer, and what is and all these the case studies that I present are all in residential context. So what you're seeing on the screen right now is a very simple way to engage with the consumer. This is a home energy report. This comes along with your energy bill, and what it tells you is very it keeps communication to a very simple and direct communication, which says, okay, some key analytics on how are you performing with respect to your neighbors. Is your performance in some sort of band? Are you performing well? Are you energy efficient? It goes on further to ask you, would you like to take a survey and inform, say, the utility or the service operator on what something that will be able to help them to make more informed assessments of your energy use. And then there is some information on what kind of energy saving tips that you could use. So, mind you, people are not interested in generic tips. Maybe initially they are, but not in the long run. And so, therefore, having a survey, being able to give customized inputs makes it interesting. And what does it cost? It costs really next to nothing. And across utility sectors, there have been 1 to 3% energy savings per household. So basically, no investment and just a behavioral nudge, and people start uh, incorporating energy efficiency and participating in some sort of demand response. This next talks about how consumers engage with pricing. So in the previous example, we were not really talking about when a consumer has to turn off things, when a consumer has to take an action, and therefore it was a very high level sort of demand response action. But with this case study tells you how you could actually nudge a consumer to or a user to take action during peak periods when say you as a grid operator or a service operator would like to flatten out the grid, flatten out the demand curve. So this is a case where the users have access to a mobile app, a user-friendly mobile app. The grid operator or the service operator purchases energy, has purchase agreements for energy a day ahead. They set uh, uh, prices for the next day in half-hour intervals, and and basically, if you are not operating on peak, or if you shift some of your um, your appliances or usage out of the peak, you have the incentive of spending less on energy use. And so this is something which has been done in the UK. You can see how the green line basically shows the difference in the business as usual demand response demand curve, and the demand curve after having implemented such things. Uh, and then again, when this comes back to the user also gets a detailed summary of their energy use. They feel fairly confident on what they have spent and where they have spent. And these kind of uh, uh, things help you have actually helped in this case shift at least 28% of energy use out of the peak. There's the third aspect is automated demand response, and we are seeing this happen now more and more. So, and this is basically a peak curtailment service, although it could be other things as well. And in this case, we're talking about a smart thermostat. So, smart thermostat is essentially a thermostat which is installed on in a residential home on a air conditioning system, and it has the ability to talk to the weather of that location, talk to the time of day, uh, and how utilities are engaging with this is that they have a rewards program, and they are asking consumers to install these thermostats, sign up for these rewards, and through an app they get notified that there will be a period in the day when we will uh, change the temperature of your AC from say 75 degree Fahrenheit to 76 degree Fahrenheit, or if you're comfortable with say Celsius, to shift it from say 24 degrees Celsius to 26 degrees Celsius. Um, uh, and therefore, and this control happens remote. This is happening uh, 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 through uh, through basically servers, or basically through a utility directly tweaking your air conditioners. So, so there are interesting opportunities here. You could actually end up using your AC to pre-cool a building when the demand outside is low. You could be not using air conditioner when the demand when the grid has a peak demand. And what this does is this kind of balances the grid. It also you also get the benefits without compromising on comfort. And again, how does this engage with consumers is a very transparent reporting on how many number of hours were you part of the program, when the next program is, uh, uh, what kind of rewards have you reaped in. So those kind of transparent uh, kind of engagement with the consumer adds to this whole process. So and these kind of thermostats have been able to reduce energy consumption by 10%, has been seen. So what is in it for the consumer? So for the consumer, engaging in demand response programs uh, not only means reducing energy expenses, but it is also revenue stream. So there have been instances where curtailment has or participation in demand response has led to some sort of financial or monetary benefit for consumers. Uh, when consumers start participating in demand response, it leads to a more reliable and stable grid. Therefore, better power quality, better the appliances and the infrastructure in general is safer. And finally, this does not mean that you do have to compromise on comfort. It is in fact a better another way to ensure comfort while also flattening out the demand curve. Uh, some insights from an Australian program showed on what are the consumer perceptions after engagement. So, see, we are talking about this because consumers are a key aspect of this uh, of these demand response programs, and it requires that these demand response programs be designed to engage consumers. And so, a couple of these key insights were that if there is not frequent communication, then you do not have a sustained engagement with users. Users in general find a lot of value in demand response, and they do have a shared sort of a vision of better energy future. And if as a utility or a service provider you're able to connect their individual efforts to collective efforts, then it keeps them engaged. And finally, there's also realization that it is not just energy adaptability, or sorry, not just energy efficiency, but energy adaptability, at least in a residential context that people are looking at. So, in a nutshell, or to just round it off, the design of DR program is critical. We all know DR programs work, but they do hinge on how consumers engage with it. So therefore, a design of DR program is absolutely critical in doing this. With that, I would like to wrap it off, and I would like to hand it back over to you, Apurva. Thank you so much. Thank you so much for the opportunity.
Thank you.
Thank you.
That was a very comprehensive, kind of a presentation on explaining the grid interactive net zero energy buildings, and also how it offers opportunities for the consumers and the consumer engagement aspect of this whole issue. So, thank you for that. With that, I will now request Mary Tyler Holmes, uh, who is the Deputy Director with the Indo-Pacific Office of USAID India. Mary joined USAID India Post last year, but she has extensive, as I said, experience in the South Asia region and has served in several education, democracy, and governance roles in postings in Africa, in the Balkans, the South and Central Asia, as well as Washington. And she has over 20 years of experience in the international development sector in strategic planning, project design and implementation, organizational change management, human and institutional capacity building, and so on. So, with that, over to you, Mary, to take us through how what needs, the whole issue of, um, yeah, basically the clean energy transition for South Asia and moving towards net zero emissions. Mary, over to you.
Good morning, ladies and gentlemen, and good evening for those who are joining from the United States or abroad. I hope that you all have a happy and healthy new year. Also, as we begin to face this third wave of the COVID-19 pandemic together, I hope that you all stay healthy, safe, and take good precautions. Building energy efficiency and grid decarbonization has been a key element of the US-India Energy Partnership since the year 2000. This partnership has played a catalytic role in developing programs for scaling net zero energy buildings and smart grid solutions in India as well as globally. USAID has supported the Bureau of Energy Efficiency in developing India's first building energy efficiency code, the Energy Conservation Building Code, or ECBC, in 2007. This was updated in 2017 with a futuristic vision and codes for net zero energy buildings with technical assistance from USAID. USAID has always focused on an integrated approach towards addressing the climate change issues that we all are facing today. Addressing the grid and building energy challenges in an integrated way is both a sustainable and as well as a responsible path towards meeting our net zero emissions commitments. As part of a joint initiative with the Government of India's Ministry of Power, which has been a key government partner of ours, USAID's ongoing Market Integration and Transformation Program for Energy Efficiency, or MATRE, as we call it, means partnership, and it actually means partnership in the Hindi language, is working with several key stakeholders to mainstream grid interactive net zero energy buildings in India. Launched in 2017, the USAID MATRE program has already made significant achievements. Some are the very first of their kind that are trailblazers for the sector, particularly in the South Asia region. USAID has been collaborating with distribution utilities for scale-up of building energy efficiency, demand response, grid decarbonization, and market transformation. For example, USAID's Smart Power for Advancing Reliability and Connectivity, also known as the SPARK program, works with the Ministry of Power to support the modernization of electricity, distribution utilities, and to make them smarter, agile, and consumer-centric. USAID's MATRE program has been at the forefront in piloting net zero energy buildings, starting with technical assistance to Nalanda University and extending to Telangana and Chhattisgarh state agencies. USAID programs have also assisted Indian Railways to develop a vision and roadmap for net zero energy moving towards decarbonization of the railway sector. USAID's market transformation approaches work on buildings institutional capacity for better efficiency in the energy sector ecosystem. India's first net zero energy buildings international seminar was organized in 2013 with USAID's assistance. The Net Zero Energy Buildings Knowledge Portal launched through the PACE program currently supported by MATRE is in its 8th year and has a breadth of learnings from the best of the global and regional practices. So far, building energy demand and grid services have been distinct discussions, with the only overlapping interface being that of renewable energy. Countries globally are now realizing that buildings are an important last mile connection to the grid of the future. And demand flexibility offered by buildings and equipment is an opportunity untapped. We initiated the ZerO-In Dialogue series in December last year to bridge this gap. And we are now excited to be with all of you at the 3rd dialogue on grid interactive net zero energy buildings on the theme of consumer engagement. We see this pertinent for easing transition towards decarbonized, decentralized, and digitized grid of the future that will support the Indian government's commitments on COP26 on net zero emissions. Thank you again for all of you who are attending today. Thank you also to our partners at MATRE, as well as the Ministry of Power and other Indian ministries who have been wonderful partners in achieving these results. Thank you very much.
Thank you, Mary Tyler, for your remarks on how the whole aspect of clean energy transition and how Metri has contributed towards that in terms of moving towards the net zero emissions as an agenda for both the countries. With that, I would now like to request Mary and the other Mary now, the Mary Ann Piette, Director, Building Technology and Urban Systems Division, and also the Director of the Demand Response Research Center with the Lawrence Berkeley National Lab. Mary oversees Berkeley Lab's building technology research activities for U.S. Department of Energy, which covers applying standards, technology analysis, and tools to accelerate deployment, new building technologies, modeling and analysis, grid interactive communications, integration with EVs, and so on. She has extensive experience with over 95 peer-reviewed publications related to demand response and energy efficiency. She also leads the new California Load Flexibility Research and Deployment Hub, which we call in as the CalFlex Hub, which pioneers new technologies and advanced communications and controls to enable buildings to receive automated dynamic pricing and GHG signals. So Mary would today be talking about this CalFlex Hub, which is a platform for advancing dynamic energy management. Over to you, Mary.
Thanks so much. Let me get my screen shared here. Let's see. Can you see my screen now?
Yes,
Let's see,
Mary.
get it in the right presentation mode. Does that work?
Yeah.
Great. Well, first of all, Purva, thank you so much for hosting me and the opportunity to present to you today. It's a great opportunity to expand on all the other discussions that you've had so far. I'll be talking about California Flex Hub, which I'll go into in some detail, but I also want to make a couple of comments. I'm going to start by talking a little about the U.S. Department of Energy work. Then I'll be focusing in on things that we're doing in California. And let me make sure that I have a little more than half an hour, about 40 minutes, I think, on the agenda, so I can take my time in explaining this, right?
Yes.
Great, thank you. Okay, so let me start with 3 slides from something called the National Roadmap for Grid Interactive Efficient Buildings. And this is about a year old now. We finished this in January 2021. And this effort for this national roadmap was a collaboration and interviews of many stakeholders around the United States to characterize what GEBs are and what we need for grid interactive efficient buildings and why we need them. So the first thing I want to say is that we want to be able to integrate the growing share of variable renewable energy. Now, as the electric grid becomes more variable, we need flexible loads to be able to ensure that the grid operates appropriately. We also want to reduce the cost of the aging infrastructure. So we have things like distribution circuits that are aging. And if we can change the electric loads on those buildings, we can actually defer the costs for upgrading a distribution circuit and help manage the grid. And that comment was made earlier about making sure that as the buildings and the grid interact, that it's going to help the overall costs if the building loads and the grid are better intercorrelated. Decarbonization is a really big issue, and I'll make a couple of comments about electrification, because in the United States and around the world, we're trying to get rid of the use of fossil fuel for heating, space heating, cooking, water heating. And if we do that without grid interactive technologies, we're going to find big challenges in the electric load shapes with the renewable integration. And then finally, we want to think about customer preferences. Today's seminar, we want to think about consumer engagement. So it's very important to make sure that as we develop these technologies, that we understand how people think about them and how people interact with them and what they understand. And the comment was made earlier that people don't really understand demand response. Of course they don't. And I want to also make sure that we're thinking about not just DR events, which actually happen historically on the peak hours, but all the hours of the year. So it may be that not only do we want to reduce some when there's a coincident peaks on the grid, but we want to increase some when there's a lot of clean electricity. And I'll make some other comments about that. So these are 4 key attributes of these grid interactive efficient buildings. Efficiency. We don't want to keep a load high in order to make it flexible. We want to do all the efficiency we can first. And that might mean better windows. That might mean better lights, more efficient fans, connected. A major attribute of these technologies is that things are connected and that we have 1- or 2-way communication. Here, this graphic says 2-way, but when we're sending prices in CalFlexHub, which I'll talk about, we're actually sending 1-way. We're sending electricity prices. And there's a really important idea why we want to use electricity prices to trigger the demand response or demand flexibility events. Because if we can make sure that the prices reflect system conditions, that's one of the cheapest ways to manage our demand response and grid flexibility. Smart. We are in a world of artificial intelligence and machine learning, and we want to harvest data from devices and use that data to better control the devices, whether it's a smart algorithm inside a heat pump or for an aggregator platform or for a utility program. We really want to encourage the use of smart energy analytics. And then the final one is flexible. Here we use the terms reduce, shift, and modulate. And in California, we've been talking about shape, shift, shed, and shimmy, and I'll talk a little about those. But we want loads that can move throughout the time of day. And the grid we have today may be a little bit different from the grid we have 5, 10, 15 years from now. So we want to understand what loads can be flexible. This next graphic is a picture of some of the key technologies that the U.S. Department of Energy has prioritized for grid interactive efficient buildings. And the very bottom are thermal energy storage technologies. Cooling loads are a problem in India, a problem in the United States, a problem all around with more climate change. We need more air conditioning, and more air conditioning is a problem for the grid. So if we can create cost-effective thermal energy storage, whether it's ice or chill water or advanced phase change materials, we're going to help make the electric loads more flexible. We may embed that in the building envelope. We may embed it in large storage tanks. Now, the orange are key technologies, and below that line are physical systems, better glazing, automated window attachments, heat pumps, HVAC combos with water heating. Then above the line are the controls. And in the dark blue are local control. A smart thermostat, which was mentioned earlier, is controlling HVAC, but it's not integrating with the water heater or the EVs or the photovoltaics. So we want devices like smart home automation systems that can cross against multiple end uses and allow us to interact with the control system that is integrating storage, EVs, photovoltaics, and building loads. Building automation systems are important. Predictive control is a really important technology. So CalFlexHub will be looking at a variety of these technologies. And multi-building control, the U.S. Department of Energy recently launched the Connected Communities program, and the Lawrence Berkeley Lab is the national coordinator. We have 10 connected community projects across the United States, and each of those are groups of buildings. So if we want to scale these technologies, we want to explore district energy, community energy, eco blocks, campuses, and groups of buildings so that we have distributed energy resources like photovoltaics and electric storage that may be at a given one single building or a campus of buildings. This is a concept of the CalFlex Hub, and the CalFlex Hub is the California Load Flexibility Research and Deployment Hub. So CalFlex Hub is about advancing the capability of buildings in California to become flexible assets for grid management. The basic concept is to have a set of research projects that are around identifying, evaluating, developing, and demonstrating what we call pre-commercial technologies. All of those will be fully automated response, and I'll go through what the projects look like. The most important thing about CalFlex Hub is we're trying to use electricity prices as the signal, as the source of information to automate the flexible loads. And we're looking at greenhouse gas technologies, a company called WattTime. So you actually can get a real-time GHG signal and follow that to make sure you're using electricity when it's most plentiful and reducing less at times when it's not plentiful. In California, we have something called load shaping demand response and supply side demand response. Load shaping demand response is based on the tariffs, and I'll talk about those in a moment. Supply side is what we do in the wholesale. So we're going to be looking at both. We will be looking at heat events, demand response events, but also continuous response capabilities. So the key concept here is a concept that's been around for a while called prices to devices. And the prices to devices concept that I shared with you is both at those local control levels that I showed in the dark blue and in the lighter blue, whole home controls, predictive controls. So we want to be able to make sure that we can listen to time of use signals, critical peak pricing signals, real-time pricing signals. And while we're focused on building loads, there's also interest in EVs. The picture there is the duck curve, and many of you may have heard of the duck. So we want to flatten the duck. In Memorial Day, which is a late May in 2019, 16% of the renewables that were generated in California could not be used. So we want to be able to make sure we can soak up that clean energy, because we actually have an imbalance in the way we control our grid. We actually have overgeneration. So in the middle of the day, we have a lot of solar. And as the sun goes down, the neck of the duck starts to peak, and the electricity is not as clean and it's more expensive. So we want to be able to use more of that midday electricity, charge those EVs, charge that thermal storage, pre-cool the building, run your dishwasher, and do the things that we can do when that electricity is cleanest and cheapest. This slide is to emphasize that a lot of the technologies we've been developing over the last decade and more have been around elite communities that are more wealthy and are benefiting from solar and storage and a lot of smart grid technologies in people's homes. But we really need to make sure that we're thinking about equity, and that we are also using technologies that will be available to all households. So not only are we using the internet to communicate the prices, but we'll be using FM broadcast. That's been demonstrated with something called Open ADR, which I'll talk about a little later also, but we really want to be able to send these electricity prices not only over the internet, but with FM, so we can get to diverse communities throughout California. This is a graph showing you the type of stakeholders that we think about in CalFlexHub. And when we think about the consumer engagement element of grid interactive low energy buildings, we want to think about the consumers and the homeowners, the community choice aggregators. We have a variety of utility deliveries models in California. We think about the equity advisors. We have a company called Rising Sun partnering with us, and they do training and workforce development. We need field demonstration partners, technical innovators, disadvantaged community leaders, software and hardware developers, and policymakers. So we're trying to create a set of activities where we're communicating a lot with these various organizations. And as we run our research projects, we share with them the results of what we're doing. This graph is another demonstration of that concept. I'm going into a little more detail. And on the left is that same ecosystem in California, but on the right is this annual hub portfolio management activity where we're actually going to be evaluating a set of key metrics to make sure that we can invest in the technologies that are performing well. So we have 12 initial projects that we're doing, 6 or more science, and 6 or more in the field. So we have a pipeline of technology. You know, really in the building sector, we have things that are ready for the market, and we have more emerging things like maybe advanced control algorithms or advanced phase change materials for thermal storage. So we have a variety of things. And every year we're going to be evaluating the performance of those technologies to make sure that we're investing in the best ones. And the California Energy Commission, who's funding the program, required that we had some sort of annual review cycle and that we kind of fail early and we're agile in our portfolio. This is a graph showing the 16 partners that we have. We have several of the universities of California: UC Riverside, UC San Diego, UC Davis, UC Berkeley. We have a large cost share from the utility Southern California Edison. And Southern California Edison announced today the largest electrification program in the country. They're going to be proposing to spend over $600 million retrofitting water heaters and heaters, space heaters, to heat pumps. And there's a lot of emphasis on equity in that investment as well. So in California, we're seeing a big effort towards decarbonization. And this load flexibility is a key element of decarbonization because, as I mentioned earlier, if we don't invest in the communication technology, the utilities are going to really have a challenge with the new electric loads and not being able to interact and enable these loads to be more flexible and integrated with the grid. I mentioned Rising Sun. That's a partner that's doing training. We have several technology companies, Skycentrics. LBNL is our DERMS provider. So we have these distributed energy resource management tools that will be the price server. I'll talk about what the state's doing. So we have a number of harvest thermal technology and e-radio, and we have 23 other partners that are actually offering test sites for what we're doing as well. I want to spend a moment around this slide. The California Energy Commission is proposing that in the future, all electric utilities have to provide the electric rate in a machine readable format. Today, when you have an electricity rate, it's in a PDF. The utilities in California have over 100 different tariffs. Tariffs for homes, tariffs for people with solar panels, tariffs for large commercial, tariffs for EVs. And the concept is that these tariffs would be available in a machine readable form. Now, they could be a static data set, or it could actually be a real-time data feed, so that the database is a stream of real-time prices that the internet connected devices or these FM broadcast devices can listen to. So it's like being able to understand every hour and the next 24 hours, what's the price of electricity? If we can get the price of electricity to reflect system conditions, we can create buildings that are operating using the cleanest electricity. So we need the price, we need to communicate it, and then we need devices that can respond to it. One of the key technologies that we've been working on, and it's actually the 20-year anniversary of OpenADR. That's an international standard, an IEC standard, a US standard. And it started from some research we were doing with you. We've had several collaborators in India, and we are very interested in using this kind of technology to create integers that represent the electricity price, and that we're sending that data to the devices continuously, so the buildings know tomorrow at noon the price is low, and I want to again run my appliances, charge my my heat pump water heater, and charge my EV. Now, I mentioned the annual assessment that we're doing. This slide shows the type of metrics that we're going to be generating for all 12 of our projects. We're going to be looking at how does the technology improve the building load flexibility? What is the price response capability? How does that impact the load shape and the customer bill? What are the cost benefit opportunities? What are the non-energy benefits? Now, a non-energy benefit might be a maintenance issue, and it might be comfort. Maybe the new technology offers more comfort. Is it usable? So we've actually invested in a lot of psychology and sociology research to understand the user acceptance associated with these technologies. And that's a critical issue when we think about the consumer, is maybe we don't even want them to know that this technology is there, and we want them to save money and to reduce their greenhouse gas footprint. But we will be doing interviews and looking at usability. Now, at the power system level, we're looking at the opportunity for the technology diffusion. Is it a technology we think has a business model? What are the system load shape impacts and the load flexibility potential? What are the avoided system costs and the greenhouse gases and the grid cost benefits? So we'll be scoring all these technologies in an annual process that's very transparent. And then you'll also see in the gray there, it says that the projects will be inclusive of disadvantaged community impacts. So while we're doing in the green there is the LBL modeling, and then we have a consulting firm called E3 that's doing what's in turquoise. But we'll also be doing disadvantaged community assessments in all of these. So here's a first look at 6 of the 12 projects. You're saying, what are these projects? What are you going to be doing? Well, the first one we're doing is pretty exciting. We're actually taking a smart thermostat and integrating it with a fan. So we want to make sure that, as you know, in India, Fans are very important for air conditioning. So we're actually partnering with a company called Big Ass Fans and UC Berkeley, and we're trying to test that at a senior center in Stockton, California. So we're looking at comfort, and maybe even a battery in the fan. So thinking about how to make the system more load flexible. The second project, we're going to be looking at dynamic control of heat pumps. So we have several projects that are combining heat pumps for space heating and water heating. That's probably not an issue in many of your climates, but in certain parts of India, you might want that kind of technology. We're looking at dynamic space heat for small commercial HVAC systems. So we're actually retrofitting small commercial buildings throughout California, putting in heat pumps, and then looking at both the winter and summer controls. We're integrating heat pumps with cold storage. So we have both heat storage and cold storage. And there's a picture there of a storage tank. That particular storage tank, you can actually buy it in different sizes, and you can buy it to run at different temperatures, and you can buy it for both heating and cooling storage. So that's a company called SunAmp, and we'll be testing some of their technology. We're testing an Italian storage technology called Armec. So we have a variety of these thermal storage systems where we're really trying to make HVAC loads more flexible. The next one is model predictive control in commercial and district energy systems. And that big chill water tank there is a chill water tank at UC Merced out in the Central Valley in California. And then that site, we actually changed the way they're charging the TES. That big thermal energy storage system normally charges at night, but we actually charged it in the middle of the day. It's a 4 million gallon storage tank, and they have 4 megawatts of on-site solar. And we've been changing the way we control the TES there and actually saving significant amount of carbon by using their local 4 megawatts of storage of solar photovoltaics and integrating their PV with their own storage system, which they've never done before. And then the last one, as we electrify and decarbonize in California, we're very concerned about upgrading the electrical panels in homes. And so we're working at what are called smart panels. So you may actually do a load management within the home so that you can minimize peak demand and maximize your current electrical systems. The next 6 projects are more in the field. They already have things in the field. We have a couple of companies that are developing integrated small commercial energy management technologies with distributed energy resources, grid point, and extensible energy. And so that they have current partners where they're testing AI and machine learning to do integrated control. And we're trying to facilitate them to do energy efficiency as well as demand flexibility and demand response, and listening to this signal that I mentioned earlier. We're testing integrated heat pumps and storage for hot water and space cooling. We're doing that at UC Davis and several homes in Northern California. We have another hot water and HVAC system called Harvest Thermal we're testing here in California. We have a partnership with BMW testing electric vehicles in homes. And we're also looking at EVs that can have two-way control. So the EV can actually be used if there's a power outage to power some devices in the home. So two-way bidirectional charging. And then that last one we call controls and coordination of distributed flexible loads. And here you'll see a number of sites that we're identifying, community choice aggregators and partners around the state of California. And we'll be sending dynamic prices to many demand response participants that are already in traditional DR programs, but we're setting them up to be more integrated into the new idea of getting continuous prices and working on the software to coordinate a large set of distributed flexible loads. Now, I want to make a couple of comments about some other things that we're doing in California. We have been working on something called the demand response potential studies. And we have these 4 grid services that we've been modeling to try to get a sense of how large are the flexible loads in California. We have the terms shape, shift, shed, and shimmy, where shape is around the concept of using the daily load shape as a persistent form of load shaping and value. Shedding is traditional demand response, which is maybe a 3 or 4 hour event, which is valuable like virtual generation. Now shift is about moving the load in the day. So it may be the same amount of energy, but it's changing the time that you're using energy. Whereas shed, when we curtail or shed, we may not, if we change the cooling set point, the number of tons of cooling has been reduced, and we may actually save energy as well as save demand, or we may have to catch it up at another time. Then shimmy are fast-acting ancillary services and regulation, and those are loads that can respond very quickly. So in California, we've been modeling these kinds of loads for several years now, and buildings can provide about 2 gigawatts of shed at about $200 per kilowatt of levelized costs. So in all the cases, we've been trying to say, if you take a building today, how much does it cost to get a gigawatt of shift? And we can get about a kilowatt for about $200, and we have about 2 gigawatts of shed available from buildings today. That's with existing technology, not some of the new stuff that I mentioned. So we've been modeling a variety of new end uses, and we're in the process of looking at hourly data. We have 400,000 electric load shapes from the California, the different customers. We have residential, multifamily, small commercial, large commercial, as well as industrial. This talk is about buildings, but there are tremendous potential as well in industrial facilities, in process control, in wastewater and water pumping, in bottling, and a variety of industrial loads that are also important for load flexibility. So the key thing we've been doing is trying to understand how large is the shed and the shift resource. Where is that resource in California? Is it in load pockets like Los Angeles or San Francisco? Of course, in Silicon Valley, we have very large data center loads. We want to know when those flexible loads are available and at what cost. So key takeaways from this is that there are extensive opportunities to use building loads to facilitate more renewables on the electric grid. So we need more shift. That's a key element for the duck curve. Now I have to say, we've also had power outages in 2021. We had some rolling blackouts here in California. So we had problems with the electric market, and we also cared about those hot summer DR events. At those times, right now, some of the large customers are allowed to bring on backup generators. But typically, we don't want any backup generators to come on during demand response events because of air quality issues. Often these DR events occur at the same time as some of the air quality events. So we want to be able to understand how to engage that capability. Right now, we have about maybe close to a gigawatt of demand response in California. The programs that exist today are air conditioner cycling programs. There's a little bit of smart thermostat programs, a little bit of automated critical peak pricing using OpenADR. But the utilities, because of the 2021 power outages, are beginning to offer incentives where they'll pay for the OpenADR technology. And just to talk a little about how that works, many gateways and control systems in large buildings can be retrofitted to receive a signal, and you can develop a sequence of operations so that the building, when a signal comes in, can change some of the HVAC set points. And we have a variety of projects that are generating demand flexibility metrics. In British units, we can get about 0.5 to 1 watt a square foot of shed from commercial buildings that are participating in these programs. And those are similar to the numbers that we're going to see from the CalFlex Hub. I'm going to spend a few minutes on my final slide here. The CalFlex Hub is a $16 million investment from the state of California to support research to advance the understanding of what technologies are available to advance building decarbonization and load flexibility in buildings. So the basic idea is we're going to be looking at the use of price signals. So we're going to be supporting the state's load management standards and the building codes, because the state is trying to move towards more electrification of all end uses, but making sure that those end uses have the ability to receive grid signals and can respond to them. We're also developing new technology that can deepen the response. And I talked a little about the role of thermal storage, but the role of controls is the most important for demand response. That's true for thermostats, that's true for HVAC systems, it's true for water heating, it's true for plug load control, that we need to have the control systems. We want to understand, what do consumers think? We have to make sure their bill doesn't go up. Maybe their bill is going to be the same. Hopefully it'll go down, but that's going to require us to really work with the state to develop the tariffs. So the key is that California is trying to move towards requiring that the utilities move towards system-based pricing that looks something like real-time pricing and then can reflect system conditions. Now, the carbon signal is also something that we're interested in. Some manufacturers, some owners might be willing to run the building to minimize the greenhouse gases using something like a carbon signal. They may be willing to pay a little more. And we don't know, it's not always that the carbon signal and the price signal will be aligned. In general, the cleanest times of the day are also the lowest cost times of the day, but that's only if the tariffs reflect system conditions. So that's part of the tariff design issues associated with CalFlexHub. The picture on the right is the concept of moving from static energy management to static energy efficiency to dynamic energy management. So the picture of the building shows that the building is now a place with a lot of connectivity and intelligence. We want to know about health and productivity and occupancy. We want the building to connect with multiple buildings. We know that most EVs are charged when connected to a building. In general, we don't want people to charge when they come home because of our duck curve problem. We want them to charge at work. So we're going to be working on workplace charging and making sure that commercial buildings can integrate the EVs with their own peak load and help manage that in terms of not just the traditional HVAC and lighting loads, but a load that includes the EVs. And then we need to think about groups of buildings and microgrids. So there are projects around the state where people are working on developing their own energy supply, integrating photovoltaics and electric batteries. I haven't talked a lot about electric batteries, but a lot of electric batteries are being installed when you do have solar. You have solar plus storage. So that is one of our other challenges, is making sure that the building can be integrated with the distributed energy resources and that the system is performing to minimize the utility bill and the greenhouse gases. So we are conducting this research in order to evaluate how to overcome barriers to deployment. These technologies are complex, and we know that there's a lot of training. We need to have good case studies on what's working. We need to understand usability, and we need to understand the consumer. So in the different sectors that I talked about, we will be working with homeowners, with multifamily buildings, with small commercial, large commercial, and campuses. And down at UC San Diego, we are going to be having an integrated program that looks at the campus plug loads, their on-site electric storage, their own microgrid, building loads, thermal storage, and EVs. So we're moving from not just a smart thermostat, but a group of technologies. And how do we create the controls, the baseline, the M&V, and the automation for a portfolio of activities? So I think I'll stop there. I'm a few minutes early, but I look forward to the discussion. Let's see if I can stop this sharing here.
Thank you, Mary. Uh, so I just have a few more minutes before I will have to leave and maybe join towards the end. But thanks, Mary. I think it was a great presentation on the platform that LBNL is working on, but how it offers, different, what's the purpose of the platform, how it kind of converges several things. I think it was beautifully explained by you. So I'm sure all the participants have benefited from your presentation. With that, I will now turn over to Tanmay Tathagat, who is the Director of Environmental Design Solutions, which is the implementing partner of the USAID METRI program. Tanmay is leading this program for the last 4 years, and obviously a known expert in the building energy and the cooling sectors, not only in India but globally as well, and has been working with USAID for several years now on various interventions related to energy efficiency. So, Tanmay will take us through the question answer session. We look forward to having a very, I'm sure a lot of questions have already come in. And so, over to you, Tanmay.
Thank you. Wonderful discussion so far. We have a few questions, and I request anyone who has a question to please put it in the chat, and we'll pick it up. But while we wait, there are a few that came up during the discussion, and one of them was from Craig, who talked about these price signals, and if they are, what's the benefit of moving them from hourly to sub-hourly or to minute by minute? Does it favor one kind of generation versus the other? Mary?
Yeah, that's a really good question. Right now, most of the prices we're seeing are 15-minute and hourly, but in some markets, as y'all know, that they may use 5-minute prices for ancillary services. Depending on the load, there's inertia in some loads, and they can't respond very quickly. We have found something like variable frequency drives can respond very quickly and provide regulation services. So we do see that there are different markets. In general, the CalFlex Hub is focusing on retail tariffs, retail rates, not ancillary services. But there are different markets and different price structures. And some technologies, again, electric batteries can respond very quickly also. So there are technologies that can respond to very high frequency prices. But in general, we're looking at sort of 15-minute and hourly prices. And we're doing a lot of work on thermal loads that have a little more inertia in them.
Great. And in terms of favoring a generation mix, so is it better to have a shorter term that favors a more variable generator like a solar or PV, whereas longer price signals and longer term tariffs kind of favor thermal? Is that the experience in terms of?
That's an interesting point. Well, I think that the reason we're doing a lot of work on thermal is because we're working in the building sector in this program, and the thermal loads are the largest loads in California, heating and cooling and water heating. Of course, we are also looking at electric vehicles, and as you know, the EV loads in some cases may actually be very, very large. So those aren't thermal loads. Those are, but of course they're batteries. And but in general, the main thing we're trying to do is facilitate the state of California in using electricity prices as the signal for demand flexibility. So we're trying to allow the state to prove the concept that devices can respond to price signals, and if they had prices that reflect system conditions, they will help flatten the loads continuously, both increase and decrease at the right time.
Yes, great, thank you. And Yeah, we have a lot of our experts from previous sessions as well. So I welcome Ralph and Smitha from New Buildings Institute to the discussion as well to jump in anytime. And Ralph from NBI, he's coined the term for India, the peacock curve,
The peacock,
as
yeah, I saw
opposed to
that.
the duck curve. But I'll pick up a question on buildings. How do you look at integrating this requirement or this whole future of a flexible grid as a part of new buildings? So, a lot of our
Yeah.
discussion has been on existing buildings, but in India, for example, we're seeing this urbanization and a rapid growth of new cities and new buildings. So,
Yeah.
what does one need to do to look at new buildings?
Yeah. Well, one thing California has done for the last 5 years is require that HVAC systems in commercial buildings have the capability to receive an open ADR signal. So they actually are requiring the use of open ADR for both lighting and HVAC, and that's moving into small. So let me make a comment about open ADR. For large buildings, a gateway can be at the building that's connected to Wi-Fi. But for smart thermostats, it's actually a cloud application. So the utility sends an open ADR signal from cloud to cloud, and then from the cloud to the homeowner is proprietary. That's a different architecture. So there's a variety of architectures when we think about the communication system, but those are things that the local authorities working on building codes can explore and work with utilities to move towards common standards. And that's one of the key things. The other one is around the load flexibility. Thermal energy storage is one of the technologies that historically was not valued in the building codes, but in California, we use something called time-dependent valuation to try to make sure those technologies are valued in the code.
Yeah, I think that's, in fact, we see a lot of that in new buildings where there is an opportunity to integrate storage of various kinds now at a fairly affordable cost, and that would definitely be something that the codes could nudge in. Uh, we've we have a question from Paul in the chat box, who's a doctoral researcher, and he has a question about the sociology and psychology related studies. So how people are getting accustomed to such technologies and how are they accepting such changes? Uh, and uh, and also one question about thermal energy storage systems. Other than being applied to HVAC, are there any other usage for thermal energy storage that you have in your pilots? So one is about how do people get accustomed and accept these and on technology.
Yeah. So we let me say that right now, electric utilities recruit customers with incentives. So they will recruit them, and they'll pay for a smart thermostat. One of the utilities is paying $1,000 if they can access your electric battery. You may have a solar and storage system, and they want to be able to do a virtual power plant sort of thing, but that's not price response. That's actually direct load control and aggregator programs, and that's one of the things CalFlexHub is testing. Are people willing to use the electricity tariff as the trigger for the DR? In terms of how people are responding, participation in traditional DR is very low. We are trying to use prices to make it common practice, to create appliances that the state of California, I forgot to mention, the state of California is trying to require that new appliances have the ability to receive prices also. So a new a new dishwasher, a new washer and dryer. So we're trying to use the electricity price communication as a requirement for new devices.
So that also affects your appliance standards. And yeah, that's an interface where you need to definitely look at building standards, appliance standards, and the interoperability of all of these things
Exactly.
at a systemic level.
Exactly.
We have a couple of questions from Robbins who talks about who's going to bear the cost of these smart devices in your project, and are the demand response potential studies to be conducted with direct interaction with the consumers?
Yeah, so the cost of the devices, most of what we're doing is interacting with existing devices. There will be a couple of examples of where we would install the new heat pump and the new storage system, not the consumer. So because it's state-funded research, we're not asking them to buy the technology. We're not, putting them at risk. There is one related project where we're buying the heat pump and we're installing the heat pump and we're doing all that. And so that's not. And then there was a second part to that, the DR potential study.
That are you interacting directly with the consumers in this process?
So the demand response potential study is a paper study, but CalFlexHub is yes. CalFlexHub hopes to be working in, I'm guessing 40 to 50 customer sites, some of them more than others. And what we expect to do is do a few weeks here and there. We're not going to put them on the tariff completely, but we're going to test the concept of the tariff and then watch their bill. And we may give them Amazon gift cards or things like that, to try to incentivize them. So we're still working on exactly doing that. But we really want to start to test. Some of this is actually testing existing technology in new ways with the price server.
Great. And since I have Smita here, just a quick question for you. When we talk about your experience of looking at integrating these at a conceptual level, at a code level for new buildings, then we have the other aspect, not just of the demand and signaling, but also how does one use an approach from codes to add the right kind of renewables to the buildings. So, does a program like this also give the right signal or the right incentive for someone to add renewables at the building level for new buildings?
Yeah, so Tanmay, thanks for that question. So as you might know, at NBI, we've been working on the Grid Optimal Buildings Initiative, which has designed metrics. So these are design metrics for new buildings that can help quantify the grid flexibility of the building, be it at adding renewables or efficiency to resilience to its flexibility. So these kind of metrics that where in the design phase, you can create and define the grid flexibility of the building. And I see Ralph is also here and has his hand up. So I don't know, Ralph, if you want to also add to that. And in fact, we'll be talking about that in our next session as a tee up to that conversation.
Yep. Yeah. Ralph, do you have? Yep, there you are. You're on mute.
You're on mute, Ralph.
2 years running here. So Mary Ann, fantastic presentation. Thank you so much. And I did want to ask you if you could just maybe go into a little bit more detail on the diversity of the Connected Communities projects, because I know that was a big investment, or it will be a big investment by DOE. I also wanted to mention, and I don't know if you're familiar with the paper by Mark McCracken about using thermal energy storage basically to drive heat pumps both directions, basically to capture waste heat and reuse it to really drive up the COP of heat pumps. Anyway, but more about the Connected Communities.
Yeah, thanks, Ralph. So I should say we've been enjoying working with NBI over the last few years on the Grid Optimal program, and they've created an amazing dashboard of data to characterize what grid flexibility looks like in the building sector, and really excited about that collaboration. Connected Communities is, let's see, I think it's connectedcommunities.lbl.gov. I could put that in the chat, but there are 10 sites from around the country. We're still getting to know the details of them, Ralph, but I'll say that there's one campus. The campus is actually The Ohio State University, is a connected community test site. There's a couple in California. There's 10 of them. Some of them are residential, some of them are commercial, and some of them are mixed. They all have energy efficiency. They all have demand flexibility, and they all have to have photovoltaics, storage, or EVs. But Cindy Renier, who's leading the program, gave her first talk about connected communities last week, and so we actually are in the process of interviewing all of them. There were over 100 applications. It was a very competitive procurement, and DOE is spending $65 million on it. So sorry, I can't tell you about more, but very excited about that program. Heat pumps in both directions. Stanford campus has 2 large heat recovery chillers and chill water tanks and hot water tanks. And they use both. They use hot water, and they have labs, and they have cooling needs. But yes, heat recovery chillers and both hot and cold storage is a really interesting thing. And a lot of buildings have a need for both. You might use the hot water for cleaning, cleaning and laundry loads, and you might use the cold water for HVAC. So there's a lot of interesting work in storage and HVAC that's to come.
Yeah,
Thank you.
I would just say, I think just, yes, the hot storage and the cold storage, but I think Mark's position was more of an ambient, almost like an ambient tank.
Oh,
which
actually,
basically could be, heated and cooled, but yeah, I think that was the theory there.
Great.
Thank you. We are just running out of time. Many questions, but I'll throw one to you, Mary, which is about from Amit Khare. He's asking about what is the role of dispatchable DR program, their role in demand flexibility compared to tariff-based programs.
Yeah. So I mentioned this concept of load shaping demand response and supply side demand response, and it's not the best terminology, but we want both. If it is critical that electricity tariffs reflect system conditions, right? I mean, if you have a flat price and variable renewables, you're not letting the consumer know. There's times when you want them to use more, and there's times when you want them to use less. So time of use is a small step in that direction. Real-time pricing is really where we want to go. And in fact, there's a lot of work on transactive energy and subscription tariffs. But we want to do as much as we can with the tariffs because there's no baseline when you're settling with the customer about how well they respond. If you run an aggregator program with demand response events, you have to calculate some sort of baseline, which is always problematic. If there's weather normalization and industrial loads that change over time. So in general, emergency programs are important. They will always be there. And you can actually have both. It's been shown Niagara Mohawk had real-time pricing and emergency programs. You want to do as much as you can with tariffs and then do the extra emergency programs with other kinds of events for DR.
Thank you. We have a few more questions, but we've absolutely run out of time now. Thank you, everyone. I see that we have a lot of participants from across the world, and I would thank everyone and pass it on to Mr. Atul Bali for a formal response and a vote of thanks. Mr. Atul Bali from NHGL.
Thank you, Tanmay. Thank you. And I think this was a very enlightening session. And I must thank the entire team and especially today's panelists and two Marys, and Mary Ann in particular, who has last delivered a very wonderful lecture. and rather given new insights. And I was just recollecting when she was just answering the last question, there was a famous quote. I forgot the name of that person, but it was that nobody can stop an idea whose time has come. So I think this net zero efficient building and interactiveness and everything like that, and the technologies that are being worked upon by CalFlex Hub, I think that is giving a new insight. And of course, I like the idea of entire, I think in that technology, and of course, load side as well as the supply side DR. Of course, the key word was equity, because in Indian context, that is the key aspect. Because last time also I mentioned nearly 40 million consumer we have just given access last 3 years. So that will be, I think, key issue to us also. And the pricing, of course, technology we are testing, and there are very use cases I rightly mentioned by Mary in the last slides and all that, giving some thermal and storage and other HVAC systems and all that. So we have to keep that. And of course, the AC as the middle class is growing in consumption. But of course, I think the 3 lecture series we have had on this net zero buildings and the sessions and the participation really enthralled me. And first was on policy and second on technologies, and now this was on consumer engagement. And I think at the end of all these 3 and furthermore one more session, I think then we can have a paper, something come out with the summary of that, and that will give a new insight. And really, but I think that consumer engagement effect, I would like to add one thing, because it would not be only the pricing, because in certain cases was the first was referred by Mr. Piyush, started with today's session. He was mentioning so some pricing and the benefits being accrued to the consumer, because it will not be the pricing alone. We need to make them aware, because awareness, attitude, and the participation, these are the key stages. Because just not pricing would help. Pricing to advanced stages, but other need to participate in that effort. But otherwise, that will not affect the richer one whom we're targeting as such. It has to be all mass, and that will be the key benefit. And really, I appreciate all the panelists who have found time and given this insightful presentations today, and all the participants who really enriched the entire session, and the EDS team, Mr. Tanmay, of course, and Apurva, key, I think, enabler in this concept. And we are happy to associate with the program. And again, I extend my heartfelt thanks to all the participants in this session. Thank you. Thank you very much.
Thank you. So a heartfelt thanks to everyone who made this happen and everyone who participated today for really active and engaging session. We would like to just let everyone know that the next dialogue in the ZerO-In series is on January 19th, which is themed on enabling policies. This 4th dialogue will feature Smita Gupta and Alexei Miller from New Buildings Institute. They will talk about the grid optimal buildings and discuss the behind the meter distribution energy resources, utility best practices, design and operation of building strategies, and the approach to overcoming barriers and expand demand flexibility using different strategies. The registration link is being provided in the chat box. You will also receive invitations. We look forward to hosting you again. As you know, this dialogue will culminate in a white paper that will bring in the insights from all of these sessions and your questions to lay the foundation for grid interactive net zero energy buildings in India in partnership with NSGM. We've talked about the future work, including this really wonderful approach of looking at developing a roadmap, which is in wide consultation with everyone, a strategy which is all encompassing, and then doing pilot projects, studies to look at an incremental way which ensures that we move in the direction of having the grid flexible, interoperable, and to the benefit of all the consumers. So USAID programs continue to work with all the stakeholders as a part of this long-term strategy to support decarbonization of the grid and the net zero emission strategies for the country. With that, I thank you all once again, and we will close the session. Thank you.
Thank you.